Alright, so this is now going to be the pre-lab for Coelimate Lab number 1. Specifically, it's going to be going over the intended dissections, just so you have an idea what you're looking at in the pictures, for the quahog, which is a hard-shell clam, the squid, and the earthworm. Now keep in mind, for these labs, you need to identify the parts I'm going to show you. Also, there are a list of questions at the end of each quote dissection that's online, dealing with definitions and questions you can either pull from the PowerPoint that I posted online or from my pre-lab I'm going to go through right now with you. Alright, so let's see. Coelimate means that, again, these creatures are going to have a true body cavity, often called what's known as a tube within a tube body plan, meaning that they have all three germ layers, ecto, meso, endoderm, and the mesoderm is completely encircling the endoderm with a space between the mesoderm and the ectoderm, creating cavities. I mentioned this last time, like your thoracic cavity, your abdominal pelvic cavity. What does that do? It gives space. That space is going to be for better mobility. It's going to be also, more importantly, for the development of more advanced organ systems. Alright, so first major group of coelimates is going to be mollusca. Now, for mollusca, again, understand there's going to be a couple classes in here. We have Polyplacophora, which is, they're called chitons, look like weird little shellfish creatures, almost like a snail, but it has 8 calcareous plates on its back, meaning Polyplacophora, many plates. Then gastropoda is what you would think of. Gastro means stomach, pod means foot, so basically you slide along your belly is what it's saying. Like a snail, think of like a slug, think of like a conch, a whelk, those types of things. From there, then you go to bivalvia. Bivalvia, valve means shells, so it's a shell that has, it's an organism that has 2 shells. Now the shells are going to open laterally, not dorsoventrally, because understand, in order for a clam, in order for it to eat, it's going to have to be a filter feeder. So what it will do with one part of its body called the foot, it'll dig itself down in, and then it has 2 little siphons that stick up. One sucks water in, one pushes water out. And basically, the only thing you'll see above the muck would be like 2 little pipes. So one way to protect themselves is simply they bury themselves, and number 2, whenever they get exposed, they clam up. They have 2 adductor muscles that close them shut, which means if you ever try to shuck a clam before, they don't want to open willingly. So from that, then, there's going to be cephalopoda. Cephalopoda means a head on legs. So that would be everything from an octopus, to a squid, to a cuttlefish, to a chambered nautilus. Now, what's going to make you a mollusk? A couple different things. Number 1, you have to have a mantle. Mantle means an outside covering, which usually gives off, if you can make a shell, it'll give off calcium carbonate, which allows you to synthesize your shell, your valve. Now keep in mind, if you're a gastropod like a snail, then you're called univalve, meaning 1 shell. If you don't have one, then you're a slug, and that's another category. Bivalves I just talked about. Things like an octopus, you understand, don't have a shell. Squid does have a shell. It's an internal shell called a pen. And if you ever go to a pet store and you see, like in the bird section, the cuttlebone is the internal shell of the cuttlefish. So they do have a shell, it's just inside. But that's from the mantle. Number 2, they have to have a muscular foot. Muscular foot can be used for different things. The muscular foot of the of univalves, meaning gastropods, you would slide along them for locomotion. For bivalves, like the quahog I'm going to draw, that would be used for digging. If you are an octopus or a squid, your foot has been divided up into 8 arms. How can you tell an arm from a tentacle? Arms are shorter, they're more muscular, and they have suckers all the way from the head all the way down to the tip. They're not retractable. Tentacles are different. Tentacles are like long spaghetti things, and they have these pads on the end, and therefore those are the places where you have the suckers. These are retractable, so therefore think of them like hands, where you can like bring them up to your face if you wanted to. A squid is going to have 8 arms, 2 tentacles. All right, so enough side talk with that. Oh, also in mollusca you have to have a radula. A radula is a tongue-like structure on the inside of your mouth. These things don't have teeth, but they have these small tongue-like structures which have like these protein barbs on them. Think about it, the first time you got licked by like a cat, you thought the tongue was going to be smooth and it was felt like sandpaper. That's That's how they basically rip apart their food and chew it, is a radula. Alright, so first pre-lab then would be the quahog, the hard-shell clam. Alright, so as you understand, think of a clam, hold it down, and it's going to open up into an area kind of like that. Now this area here, which is the hinge, is called the umbo. It's the oldest part of the clam. What you will then see coming off of this are these little growth lines coming off of it. Those growth lines are called paleo lines, and they are growth lines. Unlike a tree where you would lay down an annual ring, these are laid down as fast as you can make them. Now, if I take the quahog and I hold it on the edge, you'd have an upper valve and a lower valve. Okay? In between them, where the two valves would come together, it's serrated almost like a steak knife. Those are called the teeth. The whole idea is that whenever the clam clams up, they interlock, which means it's very difficult to get it open. Now, the shell's going to have 3 layers. The outside layer that you see, like if you ever saw a fresh clam, kind of looks like almost like a thin epidermis. That is called the horny layer. Then, if you go shell hunting, and when you go to the beach and you pick up just the white shells, that's called the prismatic layer. That's made of calcium carbonate. The inner layer is called the pearly layer. That's the one everyone thinks is pretty. It's usually the inside that's also smooth too. Because understand, basically you're a creature living in a form-fitting shoebox, and therefore whenever you move, you don't want to think like your foot and you put on a shoe that's too large for you and then you run 3 miles. It's going to cause abrasions, it's going to cause blisters. You don't want that. You want something that's form-fitting. Okay? That's also why bivalves are also going to make a pearl. Some irritation came into the clam. Clams do make them as well. Oysters are the famous ones for making them. And because you can't get the grain of sand out, what you'll then do is put mother of pearl around it, basically making it rounder and easier, so when you do move, it almost acts like a shiatsu massage so you don't cause any sort of abrasions or damage to the organism itself. Now, whenever you take a clam and you shuck it, you hold it, there's going to be 2 adductor muscles. Adductor means to close. That's when you would take like your shuck knife or your scalpel and you would stick it in and cut each one. Failure to do so means the clam's not open, and you crack it open. When you do that, the clam would have 2 valves, a left and a right half. Directly on the underside of the shell is going to be a thin membrane on both sides. That's the mantle. It secretes the calcium carbonate to make the shell. On either side of that, then, you'll see these feathery structures, one on this side, one on that side. Those are the gills. The proper name of a gill is called a ctenidia. The C is silent. Smack dab in the middle is this large structure in the middle, and that's called the visceral mass. If you eat clams or oysters, what you're eating is the visceral mass. It's basically the part that has all the organs in it. If you then take the visceral mass and pull it out, it's going to look like this. Like that. Okay? Now, one valve is going to be an in-current valve, one is an ex-current valve. Usually if you hold it by, this is the foot right here for digging. That's the foot right there. It looks like a rooster comb almost. Very tough and fibrous. If you held the foot away from you with these 2 valves sticking out from you, this one is going to be the in-current siphon, this one is the ex-current siphon. If you were then to take a scalpel and cut it straight down, what you'll see is that the digestive tract of the clam is actually a horseshoe. So you would have then the mouth right there. That's the esophagus. Back here where you make your end around, that's the stomach. Coming back up is the intestines, and then you have an anus, a complete digestive tract, mouth to anus. Back here on the stomach, again, these things cannot chew. You can't see it, but there's a large proteinaceous rod back here. Think of like a mortar and pestle when you're trying to smash up pills. When the stomach contracts, it's called a crystalline style. The crystalline style will then be on the back of the stomach, and it will start to vibrate or start to twist back and forth. And what that does is it takes the food and basically chews it up and grinds it for it. But that's going to be the digestive tract of the clam. All right. Now, far more involved creature would then be the squid, which I'm upset we can't do it because it's one of the cooler dissections to do. So on the outside, kind of looks like a torpedo. And then you'd have, I'm not going to draw them all, you'd have 8 arms which are where the foot got divided up. There's suckers all the way down, and 2 tentacles with just the suckers on the pads. Okay, but there's 8 arms, 2 tentacles. Now the eyes are here. This structure right there looks like the big muscular torpedo. That's the mantle. Those are fins. The fins are going to be used everything from stability to basically a hovering propulsion to steering. So those are the 3 main functions of them. Now, when you have this, if you would have the squid in front of you, the top side of it, on the top side, on the mantle, you're going to have all these little dots all over it. Those little dots are called chromatophores. The chromatophores is going to allow the squid to change its color. Camouflage, also for communication, also to make light potentially, bioluminescent to attract prey, to deter a predator, all sorts of reasons for it. Now understand, when the creature's dead, it lacks the ability to control the chromatophores, so it looks like a bunch of like purpley pink blackheads all over the upper side of it. Okay? Now, to do the dissection, what you would do is you would take this and flip it over. So I'm just going to have the same rough outline. First thing I tell you is when you flip it over, right where the mantle and the head meet, there's going to be this big muscular tube right there. That's the X-current siphon. What I then would tell you to do is lift the X-current siphon and chop the creature's head off, because it's just in the way for right now. We'll come back to it later. What you then do is take your scissors and you slit up both sides and peel it up. What you would see when you did that, there'd be a large muscular pouch all the way down further away from you. That's the stomach. The stomach, like the clam, is going to come up, and then it's going to make a U. It's going to come back down the other side. So it makes a U-turn. So the stomach comes all the way up, and then it comes back down. That's the intestines then. Okay? The intestines is then going to empty from the anus in the X-current siphon, so you can, when the water pushes out, you defecate, and it goes out with it. Right around this area right here, it's going to look almost like it's like a bruise all around it. That's the ink sac. People, when they do dissections of a squid, they get so disappointed. They think for some reason when you cut the ink sac, like a fountain pen, it squirts ink at you. No. When you cut it open, basically it has little tiny crystals in it. When the crystals get combined with the water that's being expelled, that makes the ink. That's then going to be your screen, your smoke screen, if you will, in order to get out of Dodge if you were startled. Okay? Now, on this side, then, you would have a feathery structure. That's 1 ctenidia. On this structure, on this side, you have the same thing. Another ctenidia, 2 gills. Different color. On the outside of the stomach, there'll be 2 large muscular tubes. 1 here and 1 here. Well, this one in the middle is the X-current siphon. These 2 are the in-current siphons. So what you got to think of is this bell is like this big empty structure. So when it opens up, it causes a suction and water flows in through the X-current siphons. In order for you to get out quickly, or for you to do jet propulsion, you take that muscular mantle and you squish it down real hard and you force the water out of one hole, the X-current siphon. So you shoot out like a torpedo then from that point on. You're basically very hydrodynamic. You literally are a torpedo in the water. Now, this creature doesn't have 1 heart, it has 2 hearts. It's going to have a systemic heart for the body and 1 heart for the gill. The gill heart, if I remember right, looking at this correctly, the gill heart will be located right about there. It looks like a white little smudge. On the other side will be another heart over there. That's the cardiac smudge. Usually whenever you guys do dissections, that kind of disintegrates, or when you cut it, it's destroyed. So I usually don't keep you liable for it. Now, up above this then, you'd have the gonads up here. Okay? Now, again, if it's a female, ovaries making eggs. If it's a male, it's going to be the testes for sperm production. Separate sexes. Not a hermaphrodite anymore. Now, with that, how you tell the difference? Usually you can do it by texture as well as color. Ovaries tend to be larger and they tend to be a little harder. They're orange because of all the fat to make the eggs. They're harder again because making the eggs. If you had one that was actually ready to write, these ovaries could be enormous, which meant that the entire digestive tract could shrink down to nothing because she's ready to breed. If you would take the ovary and actually just pinch it, you'd feel these little tiny granules on your gloves. Well, those are the eggs. The male, the testes are smaller. They're kind of like a creamy white color, and they tend to be like gushy pretty much, almost like a spongy texture to them. Now, if then, once you got all that, you ripped out all the contents as I showed there, underneath there, you would see it kind of looks like an amber colored plastic. It would go from here all the way down to the base. So it looks like a pen, like a quill, like you would take it out and write with it. That is the internal shell of the squid called the pen. Now to the head. Once you had the head, there's one eye, there's the other eye. What I would have told you to do is take your scalpel, cut about halfway, about a third of the way down between the eyes, and there's this chestnut muscular structure right there. That's the pharynx, the throat. What I would then have you do is take it out, and then with your forceps, inside of the pharynx over here, there are two large beaks. They kind of look like a bird's beak. And what do? Basically, that's how you rip apart your prey. It's made of the same material, the chitin that's made up of the pen. Now, what you would then do is take the two beaks out, and then it almost looks like a flower. Where think of like a rosebud where you had three petals. These are three muscular, what are called labial palps. Labial meaning lip, but not really. Basically, just three muscular flaps. You can pull them apart, and this little tiny thing pops up in the middle. And lo and behold, if you rub your finger over it, it feels like sandpaper. That's the radula. All right, so that's the pre-lab for the squid dissection. Hopefully that helps. And last but not least then, for this edition, we have to go over another coelomate group called Annelida. Annelida are segmented worms, which would include things like Aligacheta, that's the classic earthworm, terrestrial earthworm. Polychaete, which would be marine worms. Think about like everything from tube worms, like you would have around a deep sea hydrothermal vent, to if you've been in the River Lagoon and you see a rock and there's like little tubes all over it, those are tube worms. Tube worms also have been known back, in the age of exploration with Columbus, Magellan, all them. They're ship worms. They would bore into the bottom of the boats and they would, eat the integrity of the boat. Usually whenever, during that time period, after you are given a boat, one of the first people you hire is a good carpenter, because the idea is when you're going to make it one way, and if you don't have a good carpenter, you're not making it back. So then you pick up a crew, but you gotta get a reliable carpenter to fix, because the shipworms will just destroy the bottom of it. Anyway, so Aligacheta would then be your terrestrial worms. Your Polychaete would be your marine worms. Now, marine worms, they have, all these worms are going to have what are called setae on them. Little bristles that come off of them. But when you're in the water, the bristles could be used either almost like little nails for digging. They can be used for crawling. A lot of them have the bristles come out and become flattened, so they're paddles, so they're called parapodia for swimming. So they sort of just undulate through the water. Last but not least in this group, you're going to have Hyrinidae. Hyrinidae are leeches. They're also in this group too. So, for the earthworm, Lumbricus terrestris. So, I'm sure we've all seen a worm before. Long, skinny thing. And then you're going to have the big band in front, okay? Then you're going to have a bunch of little segments in here. This is called metamerism, meaning that you have a redundancy and repeating of segments. The mouth will be located closest to the clitellum, the anus the furthest one down. This is called the clitellum. It's only used for sexual reproduction. The earthworms are going to be hermaphroditic. They're both male and female. However, they cannot self-fertilize. The sperm has to travel from A to B to cross-fertilize. So when two earthworms want to have earthworm sex, they line up and they secrete a mucus sheath around their two clitella. What then happens is they exchange sperm between them. They fertilize the eggs, and then they separate, and then they can deposit their fertilized eggs into that mucus sheath, wiggle out of it, and then the embryos are in a mucus wad in the dirt, and mom/dad go wherever the heck they want to without any sort of parental care. So these individuals are going to show what's called counter shading. They're dark on top, light on bottom. This should make sense. The main predator of these guys you think about are birds. How they're going to see them from an elevated height looking down, and how they could tell their prey is from an outline. Well, if I'm dark, I fade into the background of a dark area, and you can't tell where I begin, where I end, so it's more difficult to hunt. All right, now for the earthworm. If you have the earthworm, where they were dark on top, light on bottom, what I would tell you to do is take your fingers and basically pet your worm. You take the worm and you run your fingers along it. What you would feel, it feels like 5 o'clock shadow coming off of it. Why? Because there's 4 pairs of setae or chetae per segment. There's 4 on the left, 4 on the right. You can only feel them under a microscope. You can see them, but it looks just like 5 o'clock shadow. What are they used for? They're going to be like oarsmen on a Viking boat. Whenever the earthworm wants to dig through the ground, basically it would open its mouth wide open, and all the setae at once would go forward and go pull, and they would push forward. Okay. Well, what do earthworms eat? They eat dirt. Well, why do they eat dirt? Because they're eating the microbes that are in the dirt. The fungi, the bacteria, the roundworms, whatever they can find, they'll digest. And when they defecate out what, better dirt. Basically, earthworms, I'm sure you know, for a gardener, are a godsend because, they help to fertilize and keep the ground broken up as well. Now, but those are the setae. All right, so what you would then do to dissect this thing is you would come from the dark side, not the light side on the bottom. Why? They're going to have a nerve cord, a spinal cord, but it runs along the ventral side, their belly side. So imagine your spinal cord wasn't on your dorsal side. You don't have vertebrae. You would just have a nerve cord that runs down your belly. So I would tell you to come in from the top side so that you don't cut the ventral nerve cord so you can see it. Okay, so when you cut this open, I'll make it a little bigger so I can draw. Obviously, you'd have the mouth in front. Behind that, then, you'd see a muscular tube right here called the pharynx. Throat again, similar to what we talked about with jellies and everything else. Now, when you cut it open, the best thing to always find is a landmark. The landmarks that occur in an earthworm are white. Those are the gonads, okay? So roughly right about here, there would be two little white bodies, one on the left, one on the right, and then right behind it, two large white bodies right behind that. Those are the gonads. The ones that are more anterior are testes. The ones that are more toward the back side, posterior, are going to be the ovaries. Again, male and female at the same time. What you then do is you would take these with your probe and you would basically push them to the side. When you push them to the side, directly underneath them, you would see the heart system, the cardiac system of the earthworm. There's going to be 1, 2, 3, 4, 5 ribbon-like structures that go from left to right. Therefore, there are 5 aortic arches, not like your heart that has 4 chambers. There's 5 aortic arches, but they're underneath the gonads. Why did I draw that in? Because think, it's an arch. There's an arch, and therefore something has to go underneath the arch. That's going to be the esophagus. So here we have the pharynx. The esophagus would then run underneath the arches and pop out the other side. From there, then, there would be 2 pouches. They're both muscular. The first pouch, when you pushed on it, would feel soft and gushy. The one behind it would be rock hard. This first one is going to be called the crop. The second one is called the gizzard. Well, why is the gizzard hard? Well, because understand, these things don't have teeth, but they have to grind things up. So what you can do is a very large muscular pouch. You can store hard material, small pebbles in it, or rocks, sand, and basically as it contracts, you basically mashing up, chewing up your food, even though you don't have a jaw. From that point on, there's a tube that runs all the way back, and that's the intestines, all the way back. Now, understand, in reference, everything I drew right here is in front of the clitellum. So all the important parts are in the first quarter of the creature. The rest of it, all the way back, is just intestines. On the inside, then, what you would see are kind of like these white ribs going all the way back. That's the metamerism, the segmentation. What I would then tell you to do, last thing to do, would be to take the intestines and with your probe, push it to one side. You would see this bright, and I mean bright white thread that runs right below it all the way down. That's the ventral nerve cord. It's going to connect the brain up here all the way down. Understand, these creatures are going to be bilaterally symmetrical. When you have bilateral symmetry, that means you have to have a more advanced nervous system because now we have to coordinate left from right halves in order for the earthworm to be able to move. I'm trying to think if there's anything else to earthworm I need to talk about. I don't believe so. So that ends the pre-lab for Coelomate Lab number 1. Next time I'll go over Coelomate Lab number 2 pre-lab, which would include the dissection of the grasshopper, crayfish, and sea star. See you then.